Okay, so today's topic is indeterminate string matching algorithms. And as Priyanka already suggested some of the, like applications like where we can apply this. It is a very like useful tool in our NLP, so natural language processing. And also we can do several other things like document matching, detection of plagiarism, then bioinformatics, pattern matching, pattern recognition, etc. So our agenda today is I will be covering some of these algorithms which we widely use in indeterminate string matching. So first one is Rabin-Karp algorithm, Levenshtein Distance algorithm, Bioinformatics algorithm, and KMP algorithm. So these are some of the algorithms. With the interest of time, I would like to cover all of them, but don't know, like if in 1 hour I couldn't cover, maybe I will continue in the next session. So let me give brief introduction about myself. So already Priyanka has told some of the points about me. I have around 16 years of experience, and I have also started my career as a developer, and then I have worked in plethora of technologies, starting from .NET and then Ruby on Rails, Python, Java. For the last almost a decade, I have worked in AI, ML, and data science and RPA projects, and mostly leading the delivery of those projects. So I was leading actually the digital transformation as a part of Industry 4.0. Along with that, I was also mentoring as an industry speaker and guest lecturer. Currently, I am doing a research work in blockchain and sustainable smart cities. Uh, Even I have, like released my own book in Amazon recently. So it is regarding innovation and automation with VBA. So some of the tips and tricks I have included in my book. Also, I am married, I have 2 children. I like to trek and do off-road biking. And one of my biggest accomplishment is that I have gone solo in bike to Ladakh. So that was the biggest accomplishment I have. So let's deep dive into this topic. I will continue with an Excel file. I won't go further with this PPT. Okay, so let's understand these algorithms. Then we will see like how the coding and the syntax and all. So coding and syntax is like in any programming language, you will, if you search in the Google, you will get about like any coding or any, like these functions and class and functions you will get like which is, like built on these algorithms. But understanding this algorithm is important because then you can build your own code around this algorithm if you understand the basic concept. So let's understand the first one, that is Rabin-Karp algorithm. So here we match the string. So let's say like we have taken a string already, like this is my string. So uh, this is my base string with which I will be matching this pattern. BCE. So this is my pattern. So this is a BCE. So if you see like in the string, you can see the match, it is existing here, BCE, right? But if we do like if we put the algorithm in place and if we try to do the matching, then how we can do? Okay. So if we just see the length of this string, the first string is 13, and they take the length as m equal to 13, and the length of the second string, that is a pattern which we are trying to match, that is n equal to 3. So let's take a basic example. So here what we will do, we will put some weightage into each character. Okay, so to each character we will put some weightage. It can be the ASCII code, like ASCII code of A is 97. Likewise, you can get the ASCII code from Google and you can put the ASCII code. You can multiply those ASCII codes for all the characters. Otherwise, you can just, for the simple understanding, you can just put your way of coding. So I have just taken like 1, 2, 3, 4, and I have assigned to A as 1, B as 2, C as 3, D as 4. Likewise, I have taken till Z as 26. So we have 26 characters in alphabet. So we have taken till 26. So let's see, like if I now assign some values to this BCE string. So this is my pattern string. Now I want to assign the value. So what will be my value to this string? So my B is 2, C is 3, and E is 5. So it gives me the total of 10, right? Now if I try to, like match this of entire value with the base string, and I will see that whether I am getting this value as 10, right? So let's start. So now I am at the index 0. So this is my 0 index. So my first three length is A, right? So A is 1, 1, 1. So 1 plus 1 plus 1, 3. Now you can put your algorithm as any way, like you can put your value as multiplication also, like you can use a multiplication operator. Like I have used a plus operator, like I have used as B as I have taken as 2, and then I have taken C as 3, and then I have taken say E as 5. You can multiply it also. So it is depending on how you take the value, right? It is not, there is no hard and fast rule on it. You can use your own hashing system on this to put the values. Okay. So I have used a addition operator. So here I am getting value of 10. Now in my first three strings, first three characters, if you see, the value is coming as 3. So it is not a match. So again, I will go to the next index. So now I will move my BCE to this index as 1. So here I will move. I will again try to match with this. So now my match is like my value is of the best string is that 1 plus 1 plus 3. So which comes as 5. 5 is not again equal to 10. So I will move this to the next location, next position. So this is my position now, new position. Now my new value is, if you see, A is 1, C is 3, and A is again 1. So again it is 5. And but still it is not coming to 10. So I will again move it to the new position, to the next position basically. So I will move it. Now like this, I will compare the value and I will keep on moving it to the next position, right? So at the time when it will happen that I will be in the correct position, so here I will be here, and that time my value will be matching 10 and 10. So then I will match the strings also. It is not like that the value is matching, the characters will also match. So when the value is matching, it is an indication that now I can match my characters. So now I will match the characters. Okay, so B is equal to B. Okay, that is fine. Then the next character, C is equal to C. That is also fine. E is equal to E. Okay, that is a match. So we got the match. And what is the position? So the position is, if we put it as 0 and we start from the 0 index. So the position is the 10th position. So we get the match at the 10th position. So this is how this algorithm works. Now let's say take a very bad example. So this is a very good case. So it is a happy example, like where we are getting the exact match kind of. Now let's see take a bad example. Okay, so this is my string now. So this is my string, and the total length of the string is 11. This is a pattern DBA, and the total length of the pattern is 3. So this is fine. Okay. Now let's put some value into it. So if I put the value in the same way as I have put in my previous case. So right now I have 4, and for B I have 2, and for A I have 1. So 4 plus 2 plus 1. So that is 7. So this is my pattern value, right? Now if I see match with the first index, putting it in the first position. Okay, so now my C's value is 3. So 3 plus 3 is 6 plus 1, 7. So it is 7, right? But the string is not matching. So though I am getting a value of 7, but if I go and match the strings, like my D is not matching with C, my B is not matching with C, so it is an entire mismatch. So it is not a match. So again, I will put this in the next position. So I will just cut it and I will put it in the next position. Fine. Now, what is my C's value? Then again 3, 3 plus 3, 6, 6 plus 1, again 7. So again, it should be a match, but it is not matching, right? So again, I am putting it in the next position. So likewise, I am keeping on just, like putting and matching with the values. Though the value is matching, but the strings are not matching. So these kind of scenarios where, the values are matching, but actually your pattern is not matching. This is called the spurious heats. So your west heats basically. So your heats are west. Like you are guessing with the values, but actually the string is not matching. So this can actually waste your time. It can have the time complexity as well as the space complexity. So to avoid this kind of problem, so this is a west heats. So to avoid this kind of problem, we can put some algorithm in place and we can hash this value instead of putting the plain this addition or multiplication operator, we can actually weight these characters. Okay, so how to weight these characters? So the thumb rule is, this is a formula. So if you understand this, that is a first character. Okay, so the first character is D. Now you take any value. This 10 can be any value. So I am taking till 10, like till J. So I am taking 10. It can be 26 also. It can be any other value you want to put. That also you can put. Okay. So this 10 I am putting. So I am assuming that I am taking till 10 characters. So I am taking 10. So this is my value here. Now this m is nothing but the length of your first string. Okay, and m minus 1. So if you see this pattern only, okay, so if you see this pattern, so in this pattern your length is 3, right? So your first formula will be, your first formula is D's value is 4. Okay, then you are taking this base value that is 10. So I am assuming it is 10. You can take any value for your algorithm, and it will be then n minus 1, that is 10 to the power square, right? 10 to the power 2. So D's value into 10 to the power 2. Then the second value is B. B's value is 2. Then B's value into 10 to the power 1, that is m minus 2. Okay, so m is the length of the string. So this time it is the minus the second value, the second character. Okay, so that's why we are putting 10 to the power 1. And then the last one, that is A. So A's value is 1. 1 into 10 to the power 0, that is m minus 3. So it is the third character. So m minus 3. So m is the length of the string. So m minus 3. So this is how the formula is like taking place. Like you can put the formula like this. Now when you will matching this pattern with this string, now getting this exact match is, like the chances are less that you get the spurious heaps or the wasted heaps. The chances will be less because you won't get this exact value, because you have already hashed this, like the pattern. So this is the way of hashing the pattern. You can use another any other like valuation, like you can use this any other base value, or you can use some other formulas also. But like formulas means you can take the modulus and you can divide it by 2. So any other thing you can use, but the same thing you have to use with the base string also. So now let's start this process. So if I take this process in my initial position, that is the 0th position. So I will be taking this string. So now my value is 421 for this string, and with the valuation I have taken for this string. So if I am going with this, so if you take C's value, so C is 3. So 3 into 10 to the power 2. So let me just calculate it. Then again C, then 3 into 10 to the power 1 this time, and plus 1. So A's value is 1 into 10 to the power 0, so that is 1. So we will be coming 331. So 331 is matching with 421? No, it is not matching. So if it is not matching, then I won't go and like match the string. So I will just put my string to the next position. So this is the algorithm which tests like this. So I will be just copying this, cutting this, and I will be pasting it here. So I am putting it in my second position. Okay, so now again I will calculate this hash, the same hash which I have applied to the pattern, the same hash I will apply to the base string also, and I will just continuously check the values like this. Okay, so once this value is matched, we will get the index of this pattern. So this is how this algorithm works. So am I going very fast, or Priyanka, you can suggest me if I need to slow down on this?
I think the pace is okay. Like moderated is good.
Okay. So this is how like we can calculate, like for the second position. And if the second position is also not matching, so if you see the same characters we have now C, A, C. So if you see, like now we have to do some, like some mathematical calculations. So first what we have taken 10 to the power 2. So this part is going fully subtracting from this. This part is fully subtracting, and with this part we are multiplying again 10 and plus the unit part, right? So that we are calculating. So if you again calculate this value, so it will be coming as 3 into 10 to the power 10 to the power 2 plus, again it is a, so a's value is 1 into 10 plus 3. So this time 3 into 10 to the power 0 means 1, so I am putting it as only 3. So this is my 313. So 313 is again not matching with 421. So there is no, like spurious heat. So I am just rolling these hash functions, which is also called rolling hash. So I am just going and checking with this all these positions, the value. And when I will get the exact match, I will just put check my characters, whether my character is matching also with the same position. So this is how I need to do this. Like this is a, like thumb rule for this algorithm. Okay. Now moving on, next algorithm is Levenshtein distance. So I have some code also, Python code, but like Python code or any other code, like any this function you will get in many, like many programming languages in C# also. So you will get it easily in Google. So I have also Googled it and get the code. So it will be good that if you understand this algorithm and write the code. So that is actually more, like fruitful for understanding this algorithm fully. Okay, so I will move on to the next algorithm. Okay, so this one is actually very interesting, and this gives you actually a confidence match. So if you have two strings, you can understand that how much percentage match it is. So running this function or algorithm, you can understand that whether it's a 80% match or 85% match, and you understand that by calculating just the number of edits. So you have to calculate the minimum edit distance. So what does it mean? So if you see this formula, I think you won't be understanding anything. But if I just, and explain this entire, like this example, you will be understanding. So let's see the first thing. We have taken a base string. So this is my base string, that is A, B, C, D, G. And this is a pattern. So A, Y, C, G. This is my pattern, right? Now, if I want to match my base string to the pattern, what I need to do? So A is matching with A, I don't have to do anything. B, I have to convert to Y, so one edit. So B to Y, one edit, right? C is again matching with C, I don't have to do anything. D, I have to delete. If I delete D, that is one delete, then G is again matching. So only two edits are there. If I can convert B to Y, that is one edit. And if I can delete D, that is one edit. So then my this string, base string, will be exactly equal to my pattern. Okay. Now we will be calculating what is our minimum edits to understand that how much this percentage, this pattern is matching with this tree. Okay, so that will give us a confidence match or a good match kind of. Okay, so seeing the percentage, we can understand. Now, how this is calculated. Now, there is a matrix we can draw with this, like how we need to do this. So basically, this is done like this. So just follow this very, just put some, like give some concentration on this so you can understand. So let me take the base string. So I have taken it in a matrix. So A, B, C, D, G, this is my base string, the same string I have taken. And this is my pattern. As you can see, I have taken in the vertically, like A, Y, C, G. So this is my pattern, okay? So I have given some indexing also. So my null index is starting at 0. So this is my initial index. And then this is my first character. So 1, 2, 3, 4, 5. I have put some indexing like this. And again, this is my first character of the pattern. So 1, 2, 3, 4, I have put the indexing like this. Okay. Now let's understand this. Okay. Now see the first character. So A and this A. So this is the base string first character and this is a pattern first character. So is this A is matching with this A? Is this A is matching with this A? If it is a match, then we will just pull whatever is diagonally there. So here diagonally is 0. So we are pulling this 0. That means we don't have to do any edit. Are we editing anything? No, we are not editing anything. So we are just putting A as A. So no edit is there. That's why we are putting 0. Now, if we take as AB, now the second character, okay, so now AB with A. Now, how many edits we need to do for AB and with A? So only one edit, that is we need to delete B. So I have put as 1. So because only one edit is there, right? So if I want to, like convert AB to A, I need to just delete B. So that is my one edit, right? Now ABC. So how many edits I need to do to convert A, B, C to A? That is two edits. That is, I have to delete B and C. So that is why I have put two. Likewise, I have filled in all the other values. Okay. Now, if you see the second position, okay, so this is A and this is Y, AY, right? Now, how many edits I have to make to bring A to AY, to match A to AY? A and A is matching, only Y is not there, so I have to add Y, right? So I have to make one edit. So this is how it is, like one I have put. Now, if you see, the formula is here. If the match is there, like A to A matching, then I am just pulling the diagonal element. If it is not a match, then I will take these three, the minimum of these three plus one. Okay, so if I am considering A and AY, so this position, how I will draw the value here? I will put the value here. I will determine like with these three values. So what is the minimum of these three? So that is what is written over here, minimum of these three. So minimum of these three plus one. So here the minimum of these three is 0. The minimum is 0, 0 plus 1, 1. So if you see for all the values, you can just draw the matrix like this. So if you see A, B and AY, so what is my B and Y is matching? No, B and Y is not matching. So what is my minimum of these three? So minimum of these three will be 0 plus 1 again, so 1. Okay. Now again, if you take the C, A, B, C and AY, is my C and Y matching? No, my C and Y is not matching. So what is my minimum of these three? Minimum of these three is 1, 1 plus 1, so 2. Okay. Now if you see D, A, B, C, D and Y, AY, so D and Y is matching? No, D, Y is also not matching. So what is my minimum of these three? So minimum of these three is 2 plus 1, that is 3. So I have put 3. Similarly for G, I have put 4 because again the minimum of these three, 3 plus 1, 4, right? So this is how I am putting all the values in the matrix. Now if you see the next part, so A and AYC, right? So AYC, what is the minimum? A and C is not matching again. So what is my minimum of these three? Minimum of these three is 3, 2, 1. So 1, 1 plus 1, 2. So I have put 2. Again, if you see B and C, okay, so what is my, again, it is B and C is not matching. So what is my minimum? Minimum is 1. So 1 plus 1, 2, right? So this is how I am pulling the matrix. Now, if you see C and C is matching. Okay, so this is a match. So what I am doing, I am just pulling the diagonal element here. I am not taking the minimum of the three elements. I am just pulling the diagonal element, that is 1. So I am pulling it here. So it is 1. So likewise, I have pulled like I have done for all the values. If you see the last one also G and G. So G and G is matching. So I am just pulling the diagonal element 2 here. So it is 2, right? Now this last value of this matrix will be your number of edits actually. And it is matching also. If you see here, so we have two edits. One is you have converted B to Y. Another is you have deleted D. So we have two edits, and in the matrix also we are getting two edits, right? So this is the value of the algorithm, like the minimum, getting the minimum edit distance. Now, the important part is now how we will understand where you are editing, where you are deleting, and where you are adding, right? So either you can edit, either you can delete, or you can add. So now how you are doing it, understanding this. Now, if you see here, this two is coming here in the last value. If you see this 2 from where it is flowing from this diagonal element 2. Okay. So when it is moving diagonally, that means we are editing. Okay. So we are actually converting, right? Now, if you see here, okay. So if you see here, this G is not changing anything. Okay. Uh, this G is not changing. It is only just changing the position. So basically, we are deleting the D. If you see the second last value, that is 2. This 2 is flowing from this 1. Okay. So if you see 1 plus 1 has become 2. So this is a minimum distance, like minimum was 1. 1 plus 1 was 2. So we put 2. So if we are going left, so 2 is getting pulled from 1 actually. So we are going left. So D is deleted. So if you see, left means delete. So here we have deleted D. Okay. So we are going to left. That means we have deleted D. Okay, now again for the C. C again, it is the diagonal element, so there is no change. Okay, so diagonal element, whenever we are going, it is no change, right? Like G, there is no change. So one delete is there, that is a deletion of D. So I have written it here. So left means delete. Okay, again I am moving to diagonal. So again it is, there is no change. Now if you see here, this one has been coming from where? This one has been coming from 0, because this is a minimum element, minimum value, and 0 plus 1 is 1. So this one has been coming from 0. So that means it is a conversion, like we have converted B to Y. Okay, so this is a edit, right? Because if it is moving diagonally, it is a edit, right? If there is no change, then because if the values are matching, like C and C, then there is no change. G and G, there is no change. So there is one edit. So this is one edit. So if you see, this is one edit. So I will just highlight this cell with some other color. So this is one edit. And again, this and this is another edit where B is getting converted to Y. So this is another edit. So here we are going to left. So left means delete. And here we are going to diagonal. And the strings is also not matching. The character here is not matching. So it is a edit. So here we are getting two edits. So this is how it is happening. So likewise, we are getting the edit distance. Okay. Now let's take another example. So here we have the string as ABC, and here we have a pattern as ABCD. Now in order to convert ABC to ABCD, so this is how I have pulled a matrix. So A and A, there is no change actually. So it is 0. So if you see also, like how many edits will be there, we have to just add one character, that is D. Then ABC will be, like equal to ABCD. Okay, so there will be only one edit. So only one value we are getting also in the last. So this is our value, the result, that is 1. Okay, so if you see here, now this one is coming from where? This one is coming from this 0, because this is the minimum value here out of these three cells. So 0 plus 1 is getting 1. So when we are moving up, this is a add. So we have to add one character here. So as I told that if I am moving to left, then it is a delete. If I am moving diagonal, it's a edit. If I am moving up, then it's like we are adding a character. So this is the what is the Levenshtein distance matching. I will show in the code also, like how we can get the percentage. Like what is a actually it gives in the percentage, you can get like either it's 80% or 85% or even less than 50% match. So likewise you can get. Okay. So moving to next. Shall I slow down, or any questions on this?
There are a few questions in the Q&A section, but if you want, we can take it at the end as well.
Okay, will it be okay if I take at the end? Hello?
Hi guys, like it will be completely okay, I feel. Yeah, I've got a reply saying that the speed is good. Yeah, we can take it at the end.
Okay. So this is how the Levenshtein distance is working. So let's move to another algorithm called Bioinformatics algorithm. So this is also a very interesting one. So let's understand this. So these are actually, like different kinds of algorithms, and they have their own pros and cons. So we can use it to them accordingly. So Levenshtein distance we can use when we had to get the, like the percentage matching, like how much a string is matching. And this is very useful when we do some kind of sentiment analysis, or like we like to get some percentage, like how much percentage the match is there. Okay, so if we are good with 80 or 85%, then I think this algorithm is also good. Like we will go with this algorithm. If we are trying to get the index, like the index value, then we will get this Rabin-Karp algorithm or Boer-Murray algorithm or KMP algorithm, which will give us the exact index, like where the string is or the pattern is happening. Okay, now let's understand this. So this is my base string in this algorithm. This is indeterminate string, so I have put it as together. So this is my base string. Now my pattern is determined. So this is my pattern. So I want to see that where actually this pattern is occurring. Now with our human eye, if you see that this pattern is occurring here at the second index, right? But when we will write this algorithm, how we will do this and what is the rules for this algorithm to follow, that we will see. Now see if I am writing this pattern again here, okay? Now try to follow this. So my pattern length is 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So the count is 8. And I have to put some values to each of these characters. So that is the rule for this algorithm. Now I have put some indexing also. So the string index starting from 0. So 0, 1, 2, 3, 4, 5, 6, 7. So till 7 it is, okay. And now I am putting some values to this, to each of this character, okay. So what is the rule to put this value? The rule is, the formula is length minus index minus 1. So this is the formula. And for the last character, we are putting the length. So last character, we are not actually calculating this formula. We are just putting the length, the total length. Okay. So that's why I have put here 8, the value. For n, I have put 8. Now let's see for D. So if you see this formula, so this is like the length is 8, 8 minus 0 minus 1. So this is giving us 7. So for D, E, all the values I have calculated. Now, there is a catch. So if you see here, E should be actually like going by the same formula. If I drag this formula, then my E should be actually 6, the first 6. But why I have put 4? Because if a character is repeating, then I have to put the last value. So here the last value which I am getting is 4. So if you see here, this is the formula I have used, and E is repeating second time, and the latest value which I am getting is 4. So I have just replaced this 6 with this 4. Okay, so this is the rule. So I am just replacing this E's value with 4. Okay, so any character which is repeating multiple times, so we have to take the latest value. Okay, so this is how we need to value all these characters. We put some values to all these characters. Okay. Now let us understand that how will this work, like when we will do this matching, right? So if I take this, let me just cut this and put it in the initial position. Okay, so now I am in the initial position. Now the rule for this algorithm is I have to always start from the last. So from right to left, I need to match. Okay, now if you see here, is my aim matching with my n? Okay, so aim is not matching with n, correct? So it is not a match. Then what I will do? I will try to search whether aim is occurring in any of this match, like in any of this, like table, wherever in this table. Yes, it is occurring. Aim is occurring, and its value is 2. Okay, so if its value is 2, I will move this to the like +2 position. So right now I am here, so I will not consider this. So 1, 2, here I will move this string. Okay, now I will again try to do like, is my n and n is matching? Yes, it is matching. So now I will just try with the other characters also. If everything is matching, then this is giving my index as 2. Okay, now let's see if it is not matching. Like if my aim is not occurring in this, like when I was in the first position, my aim is not occurring here. Okay, my aim is not occurring here. Let's say the aim is not occurring here. Then I will take the length of the string, that is 8. So my last length is 8. So last character value is 8. Then I will move this string to the to +8 position. So like just excluding this 0 part, I will count like this: 1, 2, 3, 4, 5, 6, 7, 8. And I will put this string again here, and I will try to again match the last character. So this is how this algorithm works. So I have written a program also on this. So anyhow, this algorithm, understanding this concept is important, as I said. So again, this is returning the index value. Okay, so you can also try with like different strings, like matching the different patterns and all, and you try to get the index. So this is how it is working. I can try with another thing, another example. So let's say I will take this, let me just take this RMIN. So if this is my pattern to match, okay, so I will just take some valuation on this. So again, this is my 0th value. So 0, then 1. I am just indexing it, 3. And total length of my character is 4. So as I can see, 1, 2, 3, 4. Okay, and what is the valuation? So for the last character, I am putting the value same as the length of the string, that is 4. Okay, now no character is matching here, so it is fine. Then what will be the value of the r? The value of the r will be 4 minus index, that is 0 minus 1. So 4 minus 0 minus 1, so it will be 3. What will be the value of the m? So m will be again 4 minus index, that is 1 minus 1. So 4 minus 1, 3, 3 minus 1, 2. So that will be the value of the m. Now what is the value of the I? The value of the I will be 4 minus index, that is 2 minus 1. That is 4 minus 2 is 2 and 2 minus 1 is 1. So I will put 1 and the last character is 4. So this is my value. Okay. Now let's try to find this in this string. Okay. So instead of this, I will just copy this. I will put it here. Okay. I will just delete this. Now my pattern 1 is this. Okay. Okay, so this is my pattern 1 and I'm again matching, starting the match. Okay, so I will be starting the match from n, the 0th value. So from the right side, sorry. So is my E is matching with n? No, it is not matching. But if E is here, anywhere here, no, it is also not here. Then where I should move? Then I should take 4, like I should move to +4 position. So considering this, excluding this, I will count from here. So 1, 2, 3, 3, 4. So I will move to this position. So I will move my string here. Okay. Again, I am just matching my from the right. Okay. So if aim is matching with n, no, aim is not matching with n. Okay. Is aim occurring anywhere here? Yes, aim is occurring too at the second position. Now where I will move to the second post, like +2 position. So I am here right now. So 1, 2. I will move here. So I will move this string here. Okay. Now if you see if n is matching, yes, n is matching. Okay, so n is matching, I is matching, also matching, m is also matching, r is also matching. So this is a match. And in which position I am getting it? I am getting it at the 6th position. So my index will be 6. So 0, 1, 2, 3, 4, 5, 6. So my index will be 6. So this is how you, like calculate this algorithm, like you do this algorithm. So you can use your own logic and do the programming also. So this is the logic you need to put. Okay. So going to the next one, that is KMP. This is the last one we have. Okay, actually, this is like this algorithms. I am actually explaining the way I understood it. It is little bit like if you go to understand by reading the books or articles, it will be little bit difficult for you guys. So, but I am just like the way I understand. So I am just explaining in the same way. Okay, so this is an important algorithm. Okay, so if you see here, my base string is A, B, C, D, E, F, J, K, L, M, some string I have taken, arbitrary string. Okay, the pattern I have taken is IJK. So if you see with the human eye, I can see that this is the pattern where IJK is occurring. Okay, so this is a match where I'm getting the match. This is a position, right? Now, if you do like now to understand this algorithm, we need to see like there is a basic algorithm actually from where this one is derived, like to like there were some cons in that algorithm. To overcome that, this algorithm has come into place. So let's understand the basic one. So basic one is that this is my pattern. I am matching with, so this is my ith position and let's say this is my jth position. So the initial position of the pattern is j and the initial position of the base string is I. So I is matching with j. No, I is not matching with j. Okay. So what I will do, I will move this ijk to the next position. Okay. So I will be putting it. Okay. Now if I is matching with b, this first position, these first two strings are matching. No, it is also not matching. Okay. So I will go to the next one. I is matching with c. This is also not a match. Okay. So I will again put it to the next one. I is matching with D. No, it is also not a match. So the first letter is also not matching. So I will put to the next one. I is matching with E. No, it is not a match. So I am putting it to the next one. Okay. I is matching with F. No, it is also not a match. So I'm putting it to the next one. G also it is not matching. Putting it to the next one. H is it is also not matching with H. So I'm putting with next one. Okay. So here it is matching. So then I am seeing the second letter. Okay. I and I is matching. Okay. Move I. But move means move the index. So if this is at the ith position and if this is the J, so what we will do is when the match is there, move J and move I. So I is going to the next position and J is also going to the next position. So now my new J will be in this position and new I will be in this position. So this I am deleting. Okay. Now whether this second character is matching. J and J is matching. Okay. J and J is also matching. It is a match. Okay. Move J again. So J's new position is this. Okay. And I also is moving to here. So both I and J is moving. Okay. Now my last character K and K is matching. Yes, it is matching. So it is a good match. It is a full match only. And we got the index at 8. So this is how there is no problem with this part, right? We understood this. Now let's see another example. Okay. So let's understand the basic algorithm, like why this KMP algorithm has arrived, or like it is invented. So let's understand the basic, like what is the basic difficulty here. Now let's take another example. So this is my base string and this is my pattern. Okay. Now I have put some indexing also. Now if you see, the ith and j is starting. This is the starting position. So A and A is matching, good match. So I am moving the j, moving the I, right? So what we have seen in the previous example. Okay. Now B and B is matching. Again, it's a match. So I'm moving the j, moving the I. So I'm deleting from the previous position. Okay. C and C is also matching. So what I am doing, I am moving the j again because it's a match, and I am moving the I again. Okay. Now D and E is matching. No, D and E is not matching. So what the basic algorithm states is, if it is not a match, then we will go back again. Like J will go back to the first position, and I will go back to the second position. So initially I have started I from here. So when I match here, this is not a match. So I will move I to the second position now. Now, if you see the problem, what is happening here is you are moving the I backward. Also, J is moving backward. Both the variables are moving backward. So since this string is already a match, like if you see, ABC is already a match, but still it couldn't identify this match. It is again going and matching the same pattern again, and it will again do the same search again. So this one was a basic flaw. So if you see, the time complexity for this one was O into O, the function of M and N. So basically, if M is the length of the base string and N is the length of the pattern string, then it will be M multiplied by N. That many times it will, like do the string matching, searching like back and forth, right? So to overcome this problem only, we have this KMP algorithm. So where the first thing we need to do is we need to like divide the string or any pattern into the prefix and suffix. Okay. So if you see this pattern itself, okay, the second example which we have taken, if you see this pattern itself, there can be many prefixes and many suffixes, right? So what can be the prefixes? The prefixes can be AB, ABC, ABCE. So all these are prefixes, and ABCEA, right? So this can be a prefix. What can be the suffix? Suffix can be B, then this is a suffix AB. So I have written all the suffixes, EAB, CEAB, BCEAB. So these are the suffixes, okay? Now we would like to see whether there is any longest prefix occurring which is equivalent to a suffix, or which is matching to the suffix. So the maximum prefix which is occurring as a suffix also, like maximum length prefix, which is occurring as a suffix also. Okay, so here if you see, we can see AB as a match, right? Which is occurring as a prefix also, which is occurring as a suffix also. So if you, in this string, if you see, AB is occurring here, AB is again occurring here as a suffix, right? So AB and AB is occurring. Other than that, the AB, I am not finding any other match. So AB is the longest match, which is, like occurring as a prefix as well as suffix. Okay, now when we understand this, we will draw a matrix, or we can say we will draw some value, like we will draw a table. Okay, so it is also called a pi table or the longest prefix suffix table, whatever. So I will call it a table only. So I am just putting some values. So if you see here, how we are putting these values. So this is my pattern. So this is my original pattern. So A, B, C, E, A, B. So I am writing this pattern again, A, B, C, E, A, B. Okay. Now if you see A, so I am just starting with, so A is occurring now once, so 0. So B is also 0, C is also 0, E is 0. Now A again occurring. So it is like same as the index 1. So if I put some index here, like 1, 2, 3, 4, like this is my first character, second character. Likewise, if I put some index. Okay. So if you see, so my fifth character is my actually the match of my first character. So I will put the value here as 1. Okay, and again my sixth character is a match, actual match of my second character, so I will put the value as 2. Okay, so likewise I will put some values here. Okay, now what is the rule, like how will you do this matching? Okay, now how we will move this I and you overcome these problems of uh like getting like just iterating back and forth with the I and J, right? So if you see here, now let's start with this matching. Okay, now this is my I, this is my J, so I am starting it here. Okay, so let's see this pattern now. Okay, now I have drawn this table and I have put some values here. Okay, so forget this, I am just deleting this index for the sake of understanding. So I have already put these values. Okay, now let's understand. So what is a thumb rule is when I will be in the I and I will be indicating to J plus 1. So let's take the initial string as 0. Now my ith value is A, right? So my I is here. I am seeing in this position. So this string is character is A. Now I am indicating to the J. J is now standing here. So I am writing it here. So J plus 1. So J plus 1 is this character. Okay. So A and A is a match. Yes, it's a match. So what I will do, I will move J to this position. So J is now in this position and I will be moving to the next position. Okay. So whenever it's a match, I am moving the I to the next position. Okay. Now let's see whether my second position. So B. So B and now J plus 1. So J plus 1 is again B. Okay, so B and B is matching. Yes, B and B is matching. So if it's a match, what I need to do? I need to move I and move J. So now my next position for I is this, and my next position of J is this. The next position, right? Now, if I am seeing I at C, so I's value is now C, right? Now, what will be the J plus 1? J plus 1 is again C. Now, again, it's a match. So if it's a match, then again, I am moving the I. So I am moving this I here and I am moving the J also. Okay, so I am moving this J. Okay, now let's see. Now follow this. Now this is critical because it's not a match. So my I's value is D. Okay, now my J's value, J plus 1 value is Z, right? Now if you say it's not a match, right? Now if it is not a match, what I will do? I will do is what? I will go to the value of E. Now I have put some valuation for E, right? So this is the valuation of all the characters. Now I will look into my table. What is my value of E? Now my value of E is 0. So I will move J again to the initial position at 0, right? So now it is indicating J plus 1A. So is the D is matching with A? No, it is still not matching. But this time I cannot put J more back because this is the initial position. This is the initial position where we have started. So this time we will move I. So now my I position will be here. Okay. So if you follow this, the I is not going backward again. Like we see in the basic algorithm, I was also going, like backward, and again it is, like iterating on the entire loop. So now actually the algorithm matches this string. So this whatever the highest pattern it could match, and it is just going forward. Okay. So now I put I forward because I cannot move J more backward, right? Because it is in the initial position. Okay. Now see if my I's position is matching with my J plus 1. So J is at the 0. So 0 plus 1 is 1. So A. So A is matching with A. Yes, A is matching with A. Very good. So I am moving J here to the next position, and I also to the next position. Right? Now my next letter is B, and I am indicating, like pointing to J plus 1. So my J plus 1 is again B is matching, that is also fine. Then I am moving the J again to the second position, okay, next position, and I am moving also I because it's a match, okay. Now I is this position, now follow here, okay. Now I is here, so I's value is A, J plus 1 is C, right? So A and C is matching, A and C is not matching. So if it is not matching, what I need to do, I said on the earlier example, I need to see the value of C. Okay. So the value of C is again here 0. So what I have to do, I have to move J again to the initial position. So I am moving the J back. Okay. Now I is still here. Now I am pointing J plus 1. So A. So A is matching with A. Yes, A is matching with A. Then I am moving I to the next position. So I is, if you follow, I is not going to the backward direction. Okay. So I am just moving I to the second next position, and I am moving J also to the next position. So if you see here, I now I's value is B. So it is pointing to J plus 1. So B again, B and B is matching. Yes. So again, I am moving J here, and I also to the next position. Now, if you see I again, I's value is C, and it is pointing to J plus 1, that is C. So C and C is matching. So that is a match. So again, I have to move I to the next position, and J also I am moving to the next position. Right? So likewise, I think I can match all of these strings, because as you can say, it is a match now. So likewise, it will match the entire string, and it will give me the index of this first, like the first character that is occurring, that is 6. So it will give me 6. So likewise, this is actually, this is actually overcoming the basic, like the flaw which we have in the basic algorithm. It is a naive algorithm. So if you see there, we are moving I backward again, we are moving J backward again. So both the variables are moving backward, and again we are reiterating on the characters. But here, if you see, only I is moving forward. Okay, so this is, I think, reduces the time as well as the complexity. So this is a great algorithm, and this is also, like gives us the good string match. So here I will stop. I will show some of the code, but again, I am telling that it will be good, like if you write all this code yourself, because now you understand the algorithm, because these codes are easily available in Google. Even I have, with due respect to the original programmers, I have also, like copied from Google only. So, but it is like that I know this algorithm. If I want, I can write my own logic also around the same algorithm. Okay. So for the, like the interest of time, I have put some algorithms here, like KMP search, and this I will put in my GitHub channel link. So this is, see, if I, sorry. Okay, so then Rabin-Karp is there. So some of the algorithms are there. So if I just go here, if you see, I have run these algorithms also. So if you see, this pattern is found at index 10. Okay, and this is again a Rabin-Karp algorithm. So this is actually giving, like all sorts of tests also with this, with this function, it is giving all sort of tests. So you can test different, like different patterns. So, and all the tests are success. So this is again, like I have taken from Google itself. So some of the sites are there where you can just search for the algorithms, you will find this code. Okay, so and again here there is a Boyer-Murray algorithm. So here also you can see all the algorithms that are running fine. So if you see ABA and this text, so ABA is occurring twice. So one at 0th position. So that is why it is showing that shift at 0, and then again it is occurring at here. Okay, again at 5 it is occurring. So likewise it is giving the results. And this is the last one, Levenshtein ratio. So I have given some two strings. So if you see, these strings are not matching completely. It is giving me 43% match, 43.47%. If I little bit give it, like a little bit more match, let's see what happens. So it is, you see, like I have given little bit, like more, matching I have given. So it is giving me 76% match. So likewise, you can get a match also. And based on this confidence level, you can go like, if you get 85% or 90%, and if you think it's a good confidence to, like take that string ahead, then it is a like, you can like, based on your requirement, you can do that. So I will stop here. I will take the question answers.
Sure. So the questions are available in the Q&A section. If you want, I can
Yes.
read them out.
Yes, I can see that. Yeah.
Okay.
Is Rabin-Karp used in GPT-3 DNA search, sequence mutation search? Yes, see, these are actually various algorithms. So based on the, like different requirements, you can use that. Okay, so there are some advanced level also, like where these algorithms are used, and in a very advanced way, you can use those things. Okay, so these are some of the, like applications I have told where you can use all these algorithms basically, but you need to see your requirement, like where exactly, like what is, like based on your situation, you can use those algorithms. What is the difference between rolling hash and spurious heaps? So I said already, spurious heaps is the wasted heaps, as I told you, like told in my example, like when your value is actually matching. So if you see here, I will go back again here. Okay, so yes. So when your value is matching, like I have given the value, initial value I have taken as 10, or sorry, the 7. So this example I had taken. So my value of the pattern was matching, but when I was trying to search in the best string, there also my value is matching, but the characters were not matching. So every time I'm trying to match my value with the, like changing my position, the value was coming same, but the characters were still not matching, right? So those are the like spurious hits, or we can say it as a vested hits. Like you are trying to match it, but the value is also not matching, but it is just taking your time, but the strings are not matching, right? So that is like the spurious, that is called spurious hits. Now, what is rolling hash? Rolling hash, I told you, like when you like put your algorithm. So I have put my algorithm here. So like this kind of like function you can put. You can use your base value differently, as I already said. You can do some modulus operations also. So based on your requirement, you can, like frame this formula, and the same formula you can use your base string also. So the pattern and the base strings formula should be matching. And where like when you were changing the position and you were just doing some like operations, like you were subtracting this first position. Like suppose I was in the initial position, right? My value was 331. Now second position I moved. When I moved to the second position, my value was 313. So I did some subtraction, I did some multiplication, and again I have taken the value of the next character, right? So weighted value of the next character. So likewise, when I am just rolling the hash, that mechanism is called rolling hash. So there is a difference between spurious hits and rolling hash. So spurious hits is just wasted hits. It is just wasting your time when the value is matching, but the string is actually not matching. Okay. Can you tell me the minimum value once again? Which one? Minimum value? Are you talking about Levenshtein distance? Okay, so let me just go. I think the Levenshtein distance, like two questions, I'm getting the same. Okay, so Levenshtein distance only. Okay, so yes, so Minimum value is minimum plus 1. So that is how you need to calculate. So if you just see the formula also, if you see that the positional value plus 1 they have taken, and out of that the minimum. So what I am doing is I am taking, so let's take any position. So if you just take D and C, so this position. So what I am taking is what is the minimum value here? 1, 2, 3. So 1 is a minimum, 1 plus 1. So 2 I am getting. Okay, so if you take G and Y, this position, G and Y. So G and Y is not matching. So what is the minimum value? Minimum value here is like I have highlighted these cells. If you see 3, 3, 4, minimum value will be 3, 3 plus 1, 4. So that will be my like how I will be like getting this matrix value. Okay. So this is how it is not the minimum value. It is minimum plus 1 you need to do. Okay. So that is how you will be pulling this matrix. Okay. So now you understand, VG? Sorry, I can't see your response. So if you just, Priyanka, if you just can continue.
Yeah, they have mentioned here. Got it. Thank you.
Okay. Can you show some real life examples, implementations of these algorithms? There are many actually. Maybe in the next some sessions I can cover some. So we have some industry, like applications where we, like use these algorithms. So yes, for the, like NLP it is used, like it is like these algorithms are used in NLP, and also for, like pattern matching and all. There are many examples. So I can share those with, I think in my next session I can share. Okay, what we have done here for the textual data, but if we do it for image analyzation, then there will be so many colors to be considered for each pixel. Okay, so I haven't gone yet into image or image pattern recognition. I am just, like understanding the string pattern here. Maybe in the next session, we can, like have some deep learning, like sessions so that we can understand the image recognitions. Please, could you share the GitHub matching code, pattern matching code? Yes, I will share that link. When this video will be uploaded, that Priyanka can
Yes.
comment on that.
So the video will be uploaded like within 2 days. So
Yes.
you can only check our playlist. We have mentioned the link as well in the chat section. So you can get our earlier sessions as well on it, and this one after a few days.
Okay, so time complexity is basically, like when you are iterating and trying to match the strings, the whatever time you are taking in the matching actually. So if we are considering the length of the best string is n and the length of the pattern string is n, then mostly like we should, like have our time complexity function as, like little bit less than the most difficult scenarios. Like if it is the most difficult, then we will have m into multiplied by n. So that is a, like maximum time complexity. So multiplication operator we don't want. So it will be nice like if we have m plus n. So only, like we have the like we have to go only one string, like we are iterating only on one string, like I show you in KMP. Like we are iterating only on the j, like we are going backward and forward. With I, we are not iterating. Like with the best string, we are not iterating backward. We are just going forward. Okay, so there actually we can calculate some time complexity function. Okay. Okay. How about left delete? Okay. Yes, I will tell this again. So if you see here, so if we go, like, see, if you like, again, I'm explaining this a little bit. So if you see the last one, G and G is matching, yes, and this two is flowing from this diagonal value two. Okay, so I said that if there is matching value, only we are pulling the diagonal value, so there is no change actually. So it is not changing anything. D and C is matching. No, D and C is not matching. And where this 2 is coming, this 2 is coming from 1. So this was the minimum value which got added to 1 and we got this 2, right? So 1 plus 1, we got 2. Now it is moving to left. So if you see, I have highlighted this also. So it is moving to left. So left means we are deleting. So we are, again, we can see here, we have deleted D, right? So this is the deletion. Okay. Again, if I see C and C is matching and the diagonal value is pulled, so there is no change. Again, if you see B and Y, again, if you see the what this one is coming from this 0, so 0 plus 1, it is coming as 1. So it is moving, like it is coming from 0 and it is moving diagonally, upward, right? So this one is actually coming from 0. So if it is diagonal, then it is a edit. So we have also can see here that B has been converted to Y. So this is the minimum edit you can do to convert this string completely to this string. Okay. And he similarly here, if you see to completely to change this string to completely this string, we just have to add D, right? So that is why this one is coming from this zero, because this zero is a minimum out of these three cells, 0, 1, and 2. So 0 plus 1 has become 1. So this 1 is coming from 0. So 1 is actually moving upward, right? So if it is upward, then it is a add. So you have to add a character. Okay. I hope this is clear. Thanks, everyone. Have a great day.